Okay, section 9.1, solving linear equations. Looks like in the form of x plus b equals c and ax equals c. Remember, x is going to be a variable. Then you got b, then c is a constant, and a is also going to be just a coefficient, okay, with the variable x, and then we're going to have a constant. So let's continue on. Determine whether the given real number is a solution to an equation. Solve the equations of those forms I just mentioned, and let's keep going here. Alright, if a and b and c are constants, okay, remember what those are from your definitions, and a cannot equal 0, then a linear equation in x is an equation that can be written in the form ax plus b equals c. And a linear equation, if you ever graph those out, they just create straight lines, okay? A linear equation in x is also called a first degree equation in x because the variable x can be written with the exponent 1, as you can tell from right there, okay? Because anything exponent 1 is always just going to be x. Or a, or whatever variable they decide to use at that time. Okay. Determine whether the given real number is a solution to the given equation by substituting for the variable and checking to see if the resulting equation is true or false. Okay, just like we've done before, we're going to say that x plus 5 equals negative 7, and they're saying that x here is equal to negative 7, okay? So what we're going to do is they're going to plug that back in like you see on number A here. So negative 7 plus 5 is going to equal negative 2, so that is true. So that is a solution, and it makes sure that this statement remains true. Well, let's look at this next one. 1.4 plus z equals 0.5, given that z equals negative 1.1. Well, let's look in here. We take the z, plug the 1.1 into wherever the z's at, just like they do here. 1.4 plus negative 1.1, it gives us 0.5, which is false because, let's see here, 0.3 cannot equal 0.5, so negative 1.1 is not a solution. Let's continue on. Let's do another one here. Notice they got 5.6 minus y equals 2.9, and they're going to say that y is equal to 2.7. So notice here, same thing as before. Whatever they're saying y is equal to, plug that in for y, which is what they do here. 5.6 minus 2.7 equals 2.9, which is true because 2.9 does equal 2.9, so 2.7 is a solution. Okay, and this final one here, you've got the absolute value, okay, with a z on the inside, minus 14 equals negative 3. Okay, well 10, well notice here the absolute value of anything on the inside right here, well the absolute value of 10 is 10. Okay, as you can see right here, 10 minus 14, well, that's going to be 14 minus 10 is 3, and notice how this 14 is larger than 10, and it's got the negative, so you're going to have negative 3 here. Well, does that work out? Does this work? No. Negative 10 is not a solution, because they're saying that this all has to equal, what? Negative 3. So, no, does not work. Unfortunately, it's false. So let's continue on. Notice that parentheses were used around negative numbers in the substitutions. This should be done to keep operations properly separated, particularly when negative numbers are involved. You're going to see me do that in class a lot. Anytime I have a negative pop up, I'm throwing up parentheses real quick. All right, let's continue on. Okay, if the same algebraic expression is added to both sides of an equation, the new equation has the same solutions as its original equation. Symbolically, if a, b, and c are all algebraic expressions, then the equations a equals b and a plus c equals b plus c, because you're adding the same amount to both sides. You're going to see me do this in algebra. What we do to one side, we have to do to the other side. Okay. Let's see here. This is, you can read about, it's going to be stepped in your notes. Okay, so I'm going to kind of go through that pretty quick, but a lot of this is going to be done through example. So let's go to our first example. So solve the equation of x minus 3 equals 7. So let's go ahead and get a pen out here. Okay, x minus 3. What we want to do is get the variable alone. So notice I have x minus 3 here. Let me go and rewrite this. X minus 3 equals 7. Since we want to get this alone, we want to look at what is the inverse of this guy right here. Well, minus 3, well, to get rid of that 3, we would add 3. And remember, going with what that one property says, what I do to one side, I have to do to the other side. So continuing on here, notice this guy reduces out, and you're going to have x is equal to 10. Well, let's check that. Let's take this 10 and put it right there, and we're going to get 10 minus 3 equals 7. Well, 10 minus 3 gives me 7, and 7 does equal 7, so that checks out perfectly. Let's continue on. Alright, let's look at this guy here. Notice everything's on the other side. It doesn't matter. We can kind of still just work with it the same way. Come back in here. Let me make my thing here a little bit thicker. Here we are. Alright, notice we've got y plus 5 is equal to negative 11. Well, we notice that plus 5, to get rid of a 5, the inverse of that is going to be subtract 5. Okay, so we'll subtract 5 from both sides. Well, here it's going to reduce out. Remember, whenever you're subtracting a negative, you're getting further in debt. So it's like you're adding these guys together. So you're going to end up here getting y equals negative 16. And we can go back in there and check. Okay, let's take this y. Okay, well, instead of y, we're going to plug in the negative 16. Okay, plus 5. And does that equal negative 11? Well, negative 11 plus 5, well, that's the same thing as saying negative 16 minus 5 is going to be 11. 16 has got the larger, and it's got the negative. So, yes, this guy right here checks out because this is going to equal negative 11 equals negative 11. So that works out great. Alright, we got another one here. X minus 2/5 equals 3/10. And like I said, you can go at this either way. You can go and try to get rid of the fractions if you want. This is a pretty straightforward and simple one. So let's go ahead and just jump straight in and just move the fraction to the other side. Notice you've got minus here. Well, let's go ahead and do the inverse of subtraction, and that's going to be a plus. Well, plus 2/5. I'm going to do that on one side, and all I have to do is do it on the other side as well. Okay, these are going to cancel out. And notice that these right here, these are going to have common denominators. Well, let's go ahead and make a common denominator here. And we're going to have, put this over this way, x equals 3/10 plus 4/10. And that's going to give us x equals 7/10. And we can go back in and check this. Let's go and take this x and plug it back in. So we're going to have 7/10 minus 2/5 all equal to 3/10. Notice we're going to have to go ahead and make a common denominator again, and that gives us 7/10 minus 4/10 all equal to 3/10. Well, 7 minus 4 is 3, so we get 3/10 equals 3/10, and that works out perfectly. All right, let's continue on. Alright, multiplication or division. Okay, both sides of an equation are multiplied by or divided by the same non-zero constant. The new equation has the same solution, where it's basically saying this. Look right here. I've got a equals b, but if I multiply both sides, okay, or notice what it says here, or I could divide both sides, okay, then it still go ahead, it makes the equation still equal, okay. Yeah, that's why I thought they showed this up here. These are all they're gonna have the same exact solution. Okay, so it doesn't change the equality of it. Okay, we're basically keeping everything balanced is what we're doing on here. Okay, and then here's the procedure, which I'll leave it in your notes, but we'll go ahead and just jump straight into the examples. Okay, we've got 5x equals 20. Well, the solution of 5x equals 20. Let's go ahead and notice here we have 5 times x. Well, if we're going to go ahead and do that, let me push this up, and I'll use red on this one. Well, the opposite of multiplication is division, and I want to get that x by itself. So let's go ahead and do 5 times x. Well, that's going to be 5 divided by 5. That gets rid of the 5 on one side. 20 divided by 5 is 4, and that's going to give us x equals 4, which we can go back in and check and go 5 times 4 equals 20. Well, 20 equals 20, and that looks good to me. Let's do another one. You'll see these a lot. This is not solved. Remember, this right here is still saying, right here, this is negative 1 times x equals 4. Well, that doesn't make sense right now, because notice here, okay, this is negative on this side. I don't have a negative over here. So what I need to do is notice, since I'm dealing with multiplication, go ahead and divide off the negative 1. And that is going to give us a final answer of x equals negative 4, which will make sense because if I put in negative 4, okay, for this, it all works out just fine, because since I put in negative 1 times negative 4 equals 4. Well, negative and negative is positive, so I get 4 equals 4. And it works out just fine. And let's do a couple more here. Let's see what they got here. We got 4x equal over 5 equals 3/10. This could also be written 4x. Notice, yes, because what they're doing, they're pulling the x out front. Okay. It's personal preference. I go both ways on this one. Let's go and just do this the old-fashioned way on this one. There's a quicker way you can kind of do this one, but we won't do that right now. Notice here that I'm going to go ahead and I've got multiplication happening here. Well, I'm going to go ahead and just do the inverse. Okay, I'm going to multiply this by the inverse, and what I do to one side, I will do to the other side. Notice by doing that, the 5's here, they cancel. The 4's cancel, leaving us just with 1. That leaves us with the x by itself. Here, notice the 3 and the 4, they don't cancel. But here, that will go to a 1. This will go to a 2. 3 times 1 is 3. And then 2 times 4 is going to be 8. That does not need to be reduced. Okay, and the reason you might have wanted to have this happen here is it's going to look a lot nicer, okay, whenever you plug the x back in. So whenever I do that, I get 4/5 times 3 over 8. Well, notice these cancel. Well, let's go and finish off, sorry. It's equal to 3/10. That's going to go to a 1. That's going to go to a 2. Well, 1 times 3 is 3. 5 times 2 is 10. And 3/10 does equal 3/10. So, all is well in the world. And I think, yep, that is it for this section. And we'll do some Hawks examples.